Hello everyone, my name is Abhishek Chaudhary and today I'll be presenting a topic on running Liquid Galaxy commands via SSH using a Flutter application. The goal is to understand how we can use mobile applications to run large visualization systems such as Liquid Galaxy itself. And without further ado, let's start by understanding what SSH actually is. SSH stands for Secure Shell. It is basically a protocol used to connect remote devices securely. It allows us to execute commands on another system while keeping our communications encrypted. This is extremely important when working with servers or distributed systems. In Liquid Galaxy, machines are not physically accessible, so this becomes extremely essential. Through SSH, our Flutter application can safely and securely communicate with our Liquid Galaxy master node. So now let's talk about why SSH is required in Liquid Galaxy. Liquid Galaxy is a multi-node system where multiple screens act together as a single unit, where each screen is run by a different machine and are controlled centrally. Direct practical direct physical interaction between these machines is usually not ideal. So SSH becomes a bridge between our Flutter application and our Liquid Galaxy system. Using SSH, our master node conveys all our actions across the slave machines. Liquid Galaxy provides us with several Linux based commands such as lg reboot and lg relaunch. These commands are executed on the master machine to control the entire setup. Our Flutter application connects to our Liquid Galaxy rig using our LG user through SSH. However, this user does not have root privileges due to security reasons. So commands cannot be executed directly and require controlled execution methods. The LG command scripts are owned by root user for security purposes, but our Flutter application connects to our system using a restricted LG user. Because of this, direct execution of LG scripts is disabled. To solve this, we use SSH pass for authentication and controlled execution. This approach respects system security while allowing automation from the app. Most Liquid Galaxy commands do not talk to Google Earth directly through an API. Instead, they write instructions to system monitored files, such as query.txt, which is continuously monitored by Google Earth for navigation instructions. Such as for clearing visual content, we can simply clear our query.txt file. This file-based communication is the core mechanism behind Liquid Galaxy command execution. Before moving on ahead, I would like to briefly mention the SSH library choice in Flutter. Earlier, Flutter used to use .ssh package for SSH connectivity. However, this package is no longer compatible with .3 and modern Flutter applications. Instead, we use .ssh2 package, which is written entirely on Dart and is actively maintained, which makes it more stable and compatible with current Flutter releases. Migrating to Dart SSH2 ensures that our application remains reliable and future proof. Now let's talk about some important Liquid Galaxy commands which can be useful when building our own Flutter application and can be sent through SSH. For example, here we have relaunching and rebooting system commands. LG relaunch helps us restart our Liquid Galaxy services without rebooting our entire system. This is useful to refresh our visualization state and reload configurations. On the other hand, LG Reboot reboots the entire operating system. It is used when major configurations are made or in case of system failures. Understanding this helps us choose the correct command at the correct time and helps us avoid restarting when it is not required. Now let's talk about another SSH commands which is fly to locations. A Flutter application controls navigation in Liquid Galaxy through rewriting query.txt file. The commands inside the query.txt file define camera properties such as latitude, longitude, range, and tilt. This allows smooth transitions between different locations, and we can perform place searches programmatically. This replicates behavior of a Liquid Galaxy controller using only software-based control. We can also achieve directional and rotational control when working with Liquid Galaxy commands through SSH. Directional movement is controlled through XDo tool, which simulates keyboard inputs. Using this, we can move north, south, east, west. These commands are executed through SSH and remove the need of physical keyboards or controller. It allows complete navigation directly through a mobile application. Liquid Galaxy also supports automated camera motion using tours and orbits, where tours is used to define a predefined sequence of camera actions such as fly and animate, whereas orbit commands continuously rotate the camera around on a specific coordinate. These actions are triggered by adding control values inside query.txt file, which enables a fully automated visual experience directly from a Flutter interface. In conclusion, SSH control ensures secure and flexible control of Liquid Galaxy system. By understanding the internal workings of Liquid Galaxy commands and file-based communication, we can build a powerful Flutter application for navigation and visualization. Using modern tools like Dart SSH2 ensures long-time compatibility and stability. This ensures the mobile applications to harness the capabilities of Liquid Galaxy. Now let's move on to a short practical session where I'll be showcasing how we can implement our own flight function to showcase how we can navigate inside Liquid Galaxy using our own controller app. Then I'll also be adding my own directional and rotational codes using X2 tool. And in the end, we will also be discussing how we can add our own automated controller commands using tours and orbits inside Liquid Galaxy to make visualization and navigation better. Okay, everyone, before we get started for our practical session and are defining our own fly to function, I just wanted to show you how I am using the fly to function, and hopefully it gives you some ideas on how you can also use that fly to function. So here we have this payload function, which basically helps me make my KML dynamic by storing all of these parameters which are required for KML generation. So suppose you press a button for India Gate KML. This KML firstly goes to backend and then it calls the show India function. What this show India function does is it stores latitude and longitude values inside our payload variable, which calls this generate method inside our KML. This generate method, what it does is it injects these latitude and longitude values inside our KML. So for example, as you can see here, inside coordinates, we have called these latitude and longitude parameters, and it basically helps me finish my KML. Then we store all of these values inside our KML payload function. Also, range here is basically used to control the zoom levels when we use our fly2 function. Next, when we have done all of this, then we call our show KML function using our file name and then payload. Inside inside show KML, firstly we clear all the pre-existing KMLs, and then we upload the KML using what we defined before. Then we call our fly2 function where we use payload to add latitude, longitude, and range. Now, without further ado, let's get started by defining our own. So let's get started by declaring our fly2 function. And I'll name it fly2. Inside of this, we will be calling our required parameters such as latitude, longitude, and range. Then we will be adding async since we are communicating with a different machine. Inside of this, we will be adding one variable called lookat, inside of which we will be adding our required variables such as which are longitude, latitude, range, then also tilt and heading to make our SSH command much more easier and simpler to code. Also, these values are case sensitive, so you need to make sure where you use our capital letters. Now we will be adding our exec function, which is a helper function, which just ensures whether we are connected or not when sending SSH code to our Liquid Galaxy ring. So it goes like this. And this is all for our fly2 function, which helps us with navigation when working with Liquid Galaxy. First, let's start with defining our function. We'll start with move north. So I'm just gonna name it move up. inside of this we will be adding our first we will be calling of course our exec command, and then we will be adding our first SSH command, which will be us telling our Liquid Galaxy rig that we are pressing the up key. So here I also need to add display. So this is case sensitive. So here I have added display is equals to 0 to make sure that the keyboard pressing simulation occurs on our main navigation pane or our main navigation screen. And here we are first pressing down our up key, and next we will be adding a small delay between our key down and key up function. Also this is also case sensitive. Okay. This. Now we will be adding a small delay of around 500 milliseconds, which will go something like this. This 500, comma here, comma here. Next we can just copy this exec, change our key down to key up, and this is how we use X2 tool for different commands like rotation and for like something like moving left, moving right. We do the same, but we press different buttons. I'll now be adding all the different commands like moving down, moving right, moving left, and rotating, and then I'll show you the different key bindings we use for all of these different functions. So here we have all of these functions such as move down, we are just pressing the down key. For right, we are pressing the right key. For left, we are pressing the left key, and we have this delay. And for rotation, it is the same, but we are just adding control key. Next, we will be talking about adding orbiting and touring to make navigation and visualization better for our Liquid Galaxy rig. So here I have implemented a small camera automation feature for orbiting around a selected location. First, I have created an orbit look at linear function. This function takes dynamic parameters such as latitude, longitude, zoom, tilt, and bearing. Inside this function, I generate a look at camera view. And specify smooth animations using GX Fly mode, as you can see here. The key parameter here is heading or bearing, which controls the rotation angle of the camera. By changing the bearing value, we can rotate the camera around the target location. And in the end, I also store the look at in a variable called last orbit position so that we can restore the camera smoothly when the orbit stops. Next, I have also added a fly to orbit function. This function simply takes the generated look at view and sends it to Liquid Galaxy using a fly to view command. Each call of this function represents one small step of the orbit movement. After that, we have a main controller function, orbit play. Before starting, it checks whether the orbit is already running or not. to overlap no, to avoid overlapping multiple orbits, then we define a total number of steps and the time interval between each steps, which allows us to divide a full 360-degree rotation into smoother paths. A periodic timer is then started, which runs every fixed interval on each timer tick. We calculate the current bearing angle by dividing a full circle into equal steps. This bearing value is passed to the fly to orbit function, which moves the camera to the rotating position. Also, the is moving flag ensures that the commands are executed sequentially and do not overlap. Here, the orbit automatically stops either when the user presses the stop or when full rotation is completed, meaning the current steps are more or equal than the steps. Finally, is the orbit stop function, where we cancel the timer, reset orbit state, and move the camera back to the last orbit position. This ensures that the visualization remains stable and does not jump back to unrelated view. Now that we are done with our short practical session, let's just check whether our code is working or not. Firstly, I'll add my credentials here and try to connect to Liquid Galaxy. And if I press connect here, it should connect. As you can see, it has connected. Firstly, let's check whether our fly to functions are working or not. When you press on KML like India Gate, it should fly towards it. And let's check for the other KML also. Both are working perfectly fine. Next, let's just check whether our rotation commands and directional commands are working. So I press here. These are also working fine. And then move north, move south, move east and west. Now let's check whether our orbit and stop orbit commands are running or not. Let's go to India Gate KML and click on Start Tour. As you can see, our Liquid Galaxy rig is zooming towards India Gate and is rotating. Now let's just click on Stop Orbit and just see whether our rig stops or not. As you can see, our rig has stopped. Let's also check for Australia KML whether it's working for that KML also or not. And the same with this, when we press start orbit, it should zoom and then start rotating. Now let's click on stop orbit and see whether our KML stops or not. As you can see, our Liquid Galaxy rig has stopped orbiting. That's all for my presentation. Thank you for watching, and I hope you got to learn something from this presentation.